will discuss equilibrium point. So what is equilibrium point? If any dynamical system is stay in the same position that where it starts, then the point is called equilibrium point. So if a system start from here, and as time t tends to infinity, but time goes, the system stays at that point, then is called, this point is a equilibrium point. That is, of a dynamical system, equilibrium point is the solution of the system. So the equilibrium point is described the state of the dynamical system where it stays forever. So mathematically one can find equilibrium point. So for equilibrium point, so you have a dynamical system, that is x dot as a function of f of xy, and y dot is a function of x of g of xy. So this x dot, that is mean dx dt, and dy dt, this is called dy dt. So for this dynamical system, the equilibrium point can be found from the system x dot equal to 0, y dot equal to 0. So we find the solution x dot from x dot equal to 0 and y dot equal to 0. So this gives us x comma y, which is equilibrium point. Okay. So for discrete time system, x star n plus 1 equal to x star n, where n belongs to capital N, that is set of natural numbers, and in a continuous dynamical system, x dot star equal to x star equal to 0, and we discussed here for continuous system. Let us consider a preparator two species model, that is this we have shown. So in this system there are mainly four type of equilibria. One is trivial equilibria. So when we get solution x dot equal to, that is 0 comma 0, there is no population, so x component also 0 and y component also 0, so this equilibrium point is called trivial equilibrium point. At this point there are neither prey population nor predator population. The rate of change of any population is 0. And prey free equilibrium point when the first component, that is prey x equal to 0 but y not equal to 0. This is called prey free equilibrium point. This type, that is, there does not exist any prey population but predator population has non-zero solution. And predator free equilibrium point when there is non-zero x but y equal to 0. So here predator is 0, so this equilibrium is called predator free equilibrium point. So that is, there does not exist any predator population but prey population has a non-zero solution, and this is interior equilibrium point, and it can be called that coexistence equilibrium point. Okay, so when x and y both are non-zero, so this x star y star is called interior equilibrium point where both population have non-zero solution. So now we discuss the stability of the equilibrium point. So any system is said to be stable if the final value is under control, that is, the solution is bounded if the initial values are bounded in input values, or if any system is not stable, then it is called unstable. Stability are measured in two ways, so local stability and global stability. Local stability means local stability of an equilibrium point is measured within a range of interval. That is, if any value is taken within this interval, then the system will converge to the equilibrium point. So let us consider equilibrium point this E star, and we consider a range. we consider a range. So from, if we choose any point starting near to this equilibrium point, then the solution trajectory converges to this equilibrium point. So for local stability behavior of equilibrium point, there exists a region from which, if we choose any initial condition, then the solution trajectory converges to the equilibrium point. Then we call this particular equilibrium point is locally stable. And global stability of an equilibrium point is measured within any range of the system. That is, if any values is taken from anywhere of the system, then the system will converge to the equilibrium point. So if we choose the equilibrium point, that is E star, and if we draw solution trajectories from anywhere of the region of the solution space, then the solution trajectory converges to this equilibrium point. From anywhere, if we choose initial condition, that is x0 x0, the solution trajectory converges to this equilibrium point. Then we call this equilibrium point as globally stable. So after that we will discuss bifurcation, which is the main phenomenon in our Pareto system, and through which we will investigate our system. So bifurcation tells us about future of our Pareto system and also many things. So we will discuss this. Thank you very much. Please subscribe. It will help.